Okay, in this segment, hopefully I'll get you a little excited about some of the new charting features. So I'm going to narrow this general search into graphene and transistor. So this set of patents here, 1,510 patents, are just patents that have those two keywords. And so let's take a look at these and do one of the charts. And I'm going to run this evolution chart by US class. And one thing that you'll notice is that, gee, what's happening here is that here are the dates, all right, the last 12 years, and then here are all the top classes that these patents lie in. And so we can look at this and, I don't really know what this is telling me above a normal class chart, because these seem to be pretty consistent. Okay, these guys are growing, and these 977 patents is also growing. Again, 2012 is going to be a little smaller because I'm recording this in 2012, and the year's not over yet, so these will grow. But there's really not a whole lot of things here that I can tell. But one of the things we did with these charts is that we made them dynamic. So if we dive in just a little deeper, let's not look at the primary class, let's dive in and look at the mainline subclass on these and see if we can spot any unique trends in these particular graphene and transistor patents. And I can't really see anything here that I might not find otherwise in a regular chart. So we'll investigate a little further and see if we can find anything in the class subclass that might key on my investigation. And we can see here, like, look, 734. This is the subclass. 734 and 977, and there was nothing. There was nothing lived in here until 2009. Okay, so we might want to say, okay, this has to do with fullerenes, nanotubes, graphic-based structures, etc. We can also look at this one, this similar type of a trend here, but this is 742, which I can see by this by these class structures that it's actually a child of 734. So this is specifically carbon nanotubes. So what's really happening here is that these are patents that have all these characteristics of 734, but they're not nanotubes. So what are they? Well, we might want to investigate and say, why is that area growing? What is it about that area? Who is strong in that area? And of course, like all charts, I showed you on the last segment that we can change these things. We could change the date if we wanted to show the values, for example. They're going to pop up automatically. So you don't have to constantly refresh, which I think really facilitates investigating things. And I'll tell you what, the numbers get a little distracting. Let's remove those. I kind of want to figure out what these patents are. And so let's drill into them. And this isn't really any different, but here are the patents that just represent that set. And so just by scanning, I can kind of see who they are assigned to. Gosh, these are mostly applications here. See if there's any, well, we can just filter for grants like that. But I think one of the things about having that chart being so dynamic is that it allows you to investigate, and quickly you're going to want to know, what are these semiconductor patents here that have to do with graphene that are not nanotubes? And why are they, what's going on, and what technologies are they enabling, and are we missing something? So I hope you find that the charts in general, all the charts have been rewritten. They all work the same way with that very dynamic refresh. And I think what that will inspire you to do is to investigate a little further. So not just in your final presentation, right? Charts are really useful for the actual investigative process as you do this. And I think that's one of the key points that I want to make, is that yes, when you get your final set and you want to present it to your client or the management, you're going to want to chart that up so that there's some high-level overview of what's going on in this space. But kind of more than that, they help you during your investigative process, so you can kind of figure out what's going on in the marketplace. So I hope that's helpful, and let's move on to the next segment. Okay, in this segment, let's look at some of the major improvements we've done in the natural language searching area. And we'll kind of start by doing a full circle thing. So the first thing I want to do is find the patent that I want to find similar patents for. And let's find that Apple patent that is the slide to unlock patent that you use on your iPhone. And so let's type in unlock screen and search all fields for that. And let's go down to this tiny area and type in Apple. And we'll check Apple Inc. or Apple Computer and search and see what we come up with. Well, I'm not sure which patent it is, because look, they've got 217 patents that contain both words, unlock and screen. And so let's use a little aid here called the relative value index, which basically ranks patents by value. and we'll sort the RVI column descending so we can bring it to the top. It was already at the top. But this is the patent that I'm interested in. So we're going to just double click the document number and bring up the document details. So you remember this, right? It's got the images and then claim spec, all that stuff down here that you can take a look at. And we want to find similar documents though. So we're going to go Tools, Find Similar Documents, and we can use full text or claims text. Let's use full text to start, and they will bring up different results. And what we're going to find here is that we've got a list of 5.6 million documents. And why are there so many? It's because some documents in this list, like if you go to the 5 millionth most similar document, it's going to be only similar in sort of one very minor way. And so what's really important are the patents that appear at the top of this particular list. And so obviously we can see itself, it ranks second. Somehow the application's even more similar than itself, but that's the way these algorithms work. It can make a little mistake, but one of the great things about this, if we wanted to say, and this is just a really powerful feature that I don't believe anybody else offers, is if I wanted to filter this and just say, let's just look at patents. Well, I can immediately filter that set, and now I've just got patents. The other thing that we've done is that if I had facets on assignee, now here we're down to 3 million patents. So if I faceted just on assignee, well, I can tell you the top assignee would be IBM, then Samsung, and then Canon, because this list of 3 million patents starts to approach the general corpus itself. And so what we're really interested in is who are the top assignees in the top 500 here. And so we can click this the assignee facet, and we can see Apple's got 50, Microsoft's got 47, and so we don't facet the entire set. In fact, if you notice, if you do a natural language query, facet values from top 500, it says right there. So you've got a little bit different. So now let's check this thing out. Let's say, okay, we're going to look at Apple patents. It says 50, should find 50 of them. But watch what happens. And so again, remember we've got this criteria box. Here's all the language that we're using as our source. And I've got 1948 patents. It said 50. Why do I have 1948? And the reason is because it's really looking full corpus. Now if I drop down, of course, here in the assignee case, right, I've got Apple and unassigned 0, and so that's actually looking pretty good. But if we go into the US class only, we'll see, okay, class 345, which is where I'd expect to see those, has 132 patents. Again, if I filter this, I'm going to get a bigger list, because each time we look at the set, we're actually redoing a brand new natural language search, and we are only faceting on the top 500. So these facets, if you counted them all, they would add up, and they keep going below here, they would add up to 500. And so just be clear on that. But that's the beauty and that's the power of this type of analysis, because if we limited you, you did your initial query and we limited you to 500 patents, you'd be stuck only researching those 500 patents. And right? And so we want you to have the ability to dive in a little bit deeper, narrow this down, and say, okay, if I had this restriction, it had to be Apple, it had to be in this class, then rank this list by the most similar. Right? And so what's really key then is to take the most similar. And of course, if we were going to export this list, I'll show you in the next segment how you can limit it to just that top section. So that's the first component of natural language, and it does take advantage of the new refinement panel. But really better than that, and something that was a real technical challenge for our team, was to get you facets that you could use in a meaningful way. So and have them be really powerful. So enjoy that feature. You also could have gone into the advanced search window, and you're going to get the same exact results, but go to the natural language query, and you could copy and paste text here, say from a feature in a standard, or from a Wikipedia article, or from just some journal article, and say, hey, here's this sort of language describing this technology. Does anything look like that in the whole corpus? And you can actually do that, and of course add whichever collections you want, or even inside one of your research folders. So hope you enjoy that feature. I think you'll find it is an amazing time saver and an absolutely killer implementation.